Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic, mainly how we can easily use the Google Earth Engine and create the different types of animation. In Google Earth Engine platform, we can easily create different types of animation for using the different types of dataset. It can be NDVI dataset, or we can also use some air quality monitoring dataset, okay, or any dataset. How we can easily use and create the time series animation. Today's session I will try to explain all of details. So I hope after completing this tutorial you are able to make this type of animation. So here you can see this type of animation I already created. So this is the NDVI animation. NDVI animation for time series we already created. So today's session I'll try to explain about that, how we can easily create this type of NDVI animation. So I hope after completing that you can easily get it. So we'll try to start. So first of all, we have to define our study area, mainly which study area you want to work for your make the animation. So for that, if you have your shapefile, you can simply import your boundary shapefile, or if you have, you can also use the USDOS dataset from Google Earth Engine. So just simply search here USDOS dataset, USDOS. There you can easily find out that large scale international boundary polygon. Just import, and further from here I simply filter my own country, or which country you need, you simply filter. So for that, just take a variable. Suppose I put the variable name is a max, and then further I simply filter my image collection. Basically this is not image collection, it's just a feature collection. So it is stored all of country boundary polygon in the world, or world region country boundary polygon. You can easily find out from here. Just simply import, paste here the table filter I call, and then I define how I can filter. So basically I want to filter using Earth Engine dot filter dot equal. So now what's equal what? So this information we can easily find out from our table schema. So just simply take the country name, simply copy this country name and then paste here, and then give a country name. Suppose I want to work for Bangladesh country boundary, so just I put here this Bangladesh name, and this name will be US recognized name. Just you write, then you can easily find out your own country boundary shape file or boundary polygon. So now if I just try to add the layer, suppose map dot add layer, and then call the max, and also focus on the center of this boundary. So map dot center object is max. So just I try to use here that max because it's my variable name, put here the max. So now if I run the code, it show my boundary area. So this is my boundary polygon. Suppose for this boundary I want to create for make animation of NDVI or air quality monitoring, different types of parameter, or any data set you also try. Further face any problem, then I'll also guide you. So first of all, you need to import your data set, basically which data you want to make for animation time series. So I want to use here modis NDVI. So basically I want to use the data vegetation indices 60-day global 250 meter resolution. This dataset I want to use, and further I want to make the animation of NDVI. So first of all, this dataset I want to import in my code editor. So how I can import? It's very easy. Just simply copy this Earth Engine snippet from here. Just copy and just paste here. Okay. Further, just store it this collection in a variable. So for that, just take a var keyword and I put here the col equal. So now this variable is stored this full image collection. Okay, but in this image collection we find out the two band. You can see we find out the two band. One band is the NDVI, another one is the EVI. I want to work for NDVI, so just I need to select it. So just use a function, basically this function called the select function, and then put the band name NDVI. So now I simply import my image collection, and from this image collection I select for only for the one NDVI band. So now it create the collection. So now I need to define the regional bound of the animation frame. So for that, you can also define the regional bound of your animation frame. You can easily take the rectangle and then define it. Suppose I want to define, okay, so this is my regional bound. I simply put look like that. Okay, so it's also need further when I make the animation. So basically, which region you want to create, just simply take this type of border. Okay, so in this case, I just put here this type of rectangle, and I just put this variable name as a, you can put any variable name. I put the variable name, suppose region. So just I put here region. Okay. Okay. So now in this case, I simply imported the table. So basically these things provide me the polygon or boundary shape file. I can easily get it from the this feature collection, and further I import my image collection. Okay, and I select for NDVI band and store it in the collection. Okay, so after doing these things, this collection I want to convert into day of the year. Okay, day of the year I need to convert. So for that we can easily use a function, and this function will define day of the year. So let's go try to do it. So for doing this thing, just I create a variable. If you want, you can also use the same variable name. And when you want to use the same variable name, then you don't need to define the var keyword. Okay, so in this case I try to use the same variable name, suppose col. Okay, and now I create a function. It's not mandatory you have to use the same variable. If you can also use the other variable name, it's not problem. But if you just use the same variable, then you can just only use the variable name, because we already defined the var keyword in this variable. Okay, so but when you want to put any new variable, you must need to use at the var keyword. So now we try to create a function and convert this image day of the year. So for doing this thing, just define the function keyword, and put the element name, suppose img. You can put any name as a element name. So in this case I take for one image, and then create a curly bracket. In this curly bracket just put your argument what you need. So in this case I want to create all of image day of the year. So just I take a variable, suppose I put the variable name is that doy equal, and then we create the date object dot date. Okay, and now from this element, mainly image img, I put this element name, and I get from system time start. So just put here system time start. Okay, and I also put the get relative day of the year. Okay, just put here the another function. This function name is the get relative, and define day and year. Okay, so just put here day, then put here year. So now in this code I just try to write the one function. In this function I define day of the year, and what I return from this function. So just I define it, just use at the return function, return this img, and I want to return from here. So just put that img I just set with this variable, mainly doy, and call this variable name which I already defined in here, the doy. Okay, simply copy and paste here. Okay, so now it create this function. So in this function I try to create all of image day of the year. So now this function I need to connect with my collection. So this is my collection. Okay, so just I copy this collection, and for connecting just apply the map function. Just paste here, and then use at that dot map function, curly bracket start, and first bracket start and first bracket end. Okay, so now it computed. So just if I just print, suppose just print this col and run it. So we find out this type of imagery. So here you can see the 566 elements and feature you can see. Okay, we can find out all of imagery, our filtering, and also day of the year. So you can easily find out from here. So now for this type of day we try to create the animation. So basically we try to check for this specific date what is the animation we can find out. Basically it's the animation time series. So if you want, you can also filter the specific day of the year, suppose a specific month or a specific year. So for doing these things, you can also take another variable and filter the date. So for doing this thing, just take a variable. Suppose I put the variable name is that distinct day of the year. I put this type of variable DOY, and I call my collection. From this collection, we are just filtering a specific time. Suppose I just filter date, and I want to filter for a specific time, year of suppose 2019, 1st January, from year of 2000, suppose 20, suppose I put here suppose December 31. So this is my time period I put in here. So now if I just print it, so now we got this all of imagery between this time period which I selected. Okay, so now you find out that this type of imagery 46. Okay, so now after doing these things, we need to define a filter that identifies which image from the complete collection, okay, as well as match the day of year from the distinct day of year collection. So for that, just we need to filter. So we just use the filter equals, then take a variable. Suppose I put the variable name is that filter, and I define here ee dot filter dot equals, just put here the eq, or if you can also put here the equals. Okay, you can write also look like that, there is no problem, or just put the short key eq or equals. We try to define it, so we have to put the equals. So further we just put in here and define here the left field and right field. So basically in the left field I want to just make a dictionary, so curly bracket start, and also curly bracket in here, just put the curly bracket in here. So now first of all left field, so left field equal, I put here the DOY, and right field I also put here the DOY. Okay, just equal we define in here, right field also DOY, and sorry it's the right field. Okay, so not right value, we have to put here the right field. So just change it, so it's not need, just remove that, and right field. Okay, just I put here right field is the DOY. Okay, and left value is not mandatory, just remove that, just remove it. Okay, so now if I just try to print the filter, just print the filter, you can check. So we find out this type of filter equal. Okay, we put here the day of the year and day of the these things we can simply set in here. Okay, so now we have to match. Okay, we have to define a filter that identify which image from the complete collection, as well as match the day of the year from the distinct day of year collection, mainly this distinct day of the collection. So let's go try to do it. For doing this thing, just we have to define a join. So for that we try to just take a variable. Suppose I put the variable name is that join, and then put here ee dot join dot save all function. Okay, so now define here day of masses. Okay, just we put here these things. Okay, so just put here that DOY. Okay, masses we just define it, save all in here. Okay, so now if I just print the join, click the run. Okay, so it show that save all cannot read property save all of undefined. Okay, so let me check. So now it shows the cannot read properties, save all undefined. Okay, we have to use here okay, we try to write the previous code. Okay, so just we try to write, suppose just take a variable, suppose join. So just we put here the join collection and put here ee dot image collection and then join, just apply with these things. Suppose these things they of what, these things they of here. Okay, and further another one is that collection, and the col we put in here. Another one is that filter. Okay, just simply copy and paste here. Okay, so just we join collection, all of collection simply join. So if I just print, simply copy and paste here and click to the run. Okay, it show the wrong. Okay, we have to, okay, so it is the uppercase. So now I hope it got the idea. Okay, so uppercase, yes. So now it's worked. Okay, so now you find out that you can see the feature, and in this feature you can find out that 8 properties, day of the year, 0 identify about the first day, then you can see the 16 we find out this type of things. Okay, bands is the one for NDVI. Also you can see about that 32. Okay, basically day of the year you can see about that 48. Okay, so now we can create this type of day of the year. So now further, after creating and also connecting with that collection, so now apply the median reduction m with max day of y collection. So we have to just apply the median collection, then we can easily do it. So let's go try to do it. So we have to connect this collection with our join collection, this variable. Just take a variable. Suppose I put the variable name is that suppose composite or comp. I took this variable and create a function, and I put the element name, suppose img, and further we put my argument. So in this time my argument is that I want to create day of the collection and create the median. Okay, so for that just take a variable, suppose doy col. Okay, you can put any variable name, and then just use the function e dot image collection dot from images. Okay, I put here, and then just this image I get from the of masses. So just put here that image dot I want to get from masses. Okay, and further what I return from here, just need to define in here. So just I want to return from this function. So from this function we return the median composite. Okay, just put here the return this doy col, this variable we need to reduce. So how I can reduce, I want to reduce using the median. So put here ee dot reducer dot median. Okay, so now it did the median composite, but this function I want to connect with this collection. Okay, my day of year collection. So simply copy, and for collecting just paste here, and use the map function. Okay, just bracket start and bracket end. So now if I just print and check this median composite, we find out the same number of images they appear. So now run the code, but now it calculated the median. Okay, we can get the 46, and we'll also find out about that. You can see the all of imagery. So this is that specific time. Also you can see this is the another. It creates the median, this type of imagery find out in here. If you want, you can use at the average, not mandatory, but it take the middle pixel value. Okay, then we also get the more better animation. So now we this collection we just apply the animation. Okay, and for the animation we have to define our visualization. Okay, so we can easily find out different types of color from here. So you can see, just I copy this color code, just copy this color code, and this color code I want to apply in my code. So for doing this thing, just simply copy this color code and paste here, and then you can put a variable name. I just put the same variable name, it's not mandatory anything. So now create the RGB visualization image for use animation frame. Okay, so for creating this frame we have to write the code. So just take a variable, suppose RGB BIS. Okay, you can put any variable name, then equal. So in this case I want to create a function. This function help me to create the RGB visualization images for use an animation frame. So for doing these things I want to use a function. So just use at the function keyword and put the element name, suppose img, and what is my argument. Okay, so in this time my argument is that I want to create the RGB visualization image for use an animation frame. So for doing these things, just I apply here the return. So just put here the return this image dot put here the visualize function. So visualize with, I already defined my visualization parameter, so simply copy and paste here. Okay, and then clip with my study area. So just I put here the clip with study area, mainly I put the variable name for study area, you can see max. So just put here that max. So now I define it, and now define the GIF visualization parameter, and we can easily create it. So let's go try to define for the GIF visual parameter. So for doing these things, just I take a variable, suppose GIF or animation. So I put the GIF params, okay, and create the dictionary. In this dictionary define all of argument. So first argument is the region. Okay, suppose I put at the region, and region mainly your which boundary. Okay, so I already create this boundary. Okay, and it is stored in the region. Okay, I put the region, so just I keep that the region, then comma sign. Further we have to define your the dimension. Okay, dimension just I define, so just put the dimensions, and I define the dimension, suppose 6. Okay, and 600. Okay, and further if you want also dimension the CRS, mainly coordinate reference system, or frame per second. Okay, so just I put here, suppose frame per second, suppose frames per second I define, suppose 10. Okay, so I define this type of parameter. After that just try to print this animation. So just I call the my visualization parameter RGB vis, and this thing simply connect, mainly I want to create the URL. Okay, suppose I want to create the URL, so you can this type of URL, when anyone visit it they can easily get this type of animation. Okay, so for creating this URL we have to use here the, mainly we have to apply, just apply here get download URL and define here the give parameter. So this is my give parameter. Simply copy and paste. Okay. But in this case, this is my function. This function have to connect with our final median composite collection. So simply copy, and for connecting these things, just simply apply here the map function. Just use here the map function and also close this parenthesis. So now it also okay. So now we try to check it what happened. So if I run the code, okay, it show the problem. Let me check. So just put at the, let me check, it show the problem is that get download URL is not a function. Okay. So we try to, okay, get download, it show this type of problem. Let me check it. We define the region. This is boundary we define. Then dimensions. Okay, it's a wrong spelling. Dimensions. So now try to check. Okay, still problem. It show the RGB VIS is not the RGB. We define the variable name and get download from the give parameters. Okay, so also okay. So we define the region, dimension. Okay, if you want, also try to add the suppose CRS, and then check what happened. Suppose I put the CRS, you can put your own study area for the coordinate reference system. So I put here the SG, suppose 357, and also put here the comma sign. So now let's try. Okay, it's not the main problem. I think some other problem. So it show that RGB vs get download URL. Okay, so we have to mention problem this in this function. Okay, so we not download this URL. Okay, we have to get the video thumbnail. Okay, so sorry, it will be just another function. This function will be get. Just put here the get video thumb URL. Okay, so now I hope it will work. So now it create this, yeah, so we find out this type of URL. So this function will be get video thumb URL. So now if I run, click on here. So now if there is no problem, then we can easily find out the animation of NDVI. Okay, great. So we find out this type of animation. Okay, as well as if you want, you can also print this animation. So for that you can also write it. Suppose for this, just simply use at the print function, and I want to print this animation in my console tab. So just print, then put here UI dot thumbnail. This is another function. Thumbnail, and define here the two things. First one is the RGB, this visualization, and these things. After that, just put here that give parameters. Okay, just simply copy and paste here. So now run the code. So now it also visualize the region under the console tab. So we find out it also generating the thumbnail, and this is the link. From this link we can easily find out, you can see we find out this type of animation, and this is the link, you also get the animation. So basically this is the process. Using this process you also try for other country, and you can easily create this type of NDVI animation or any other data set. From that we can easily get the idea what the scenario of the vegetation changes, we can easily find out. Okay, so this is the process for creating the animation NDVI. So this process you can also try to apply for other data set, then you can easily find out that more animation video, or you can easily create this type of animation. Okay, so this is the process to try. Further face any problem, you can also contact with me, then I also guide you. So in the meantime, I also give you an announcement for our upcoming online training program. So basically this class will be start from 15 November. So if you want to join this online training program, you can easily get all of information from our website. So basically this registration is open and this class will be start from the 15th November. Okay, so in this class you will learn all of those things from beginners to advanced level. So basically this is the total 7 days online training program, and each day mainly 4 hours. 3 hours mainly live training, 1 hours for your problem solving class. And if you want to join with a 50% discount on this online training program, as soon as possible book your seat, because our seat is limited. And you can easily get all of information such as course content. You can easily get it from my website, as well as you can also get it this video description also. So here you can see all of course content I already added. So basically 2 days in a week we take the class, Friday and Saturday. Okay, so you can see all of that I already mentioned, and all of course content we still learn after completing the total 7 days online training program. So when you join our online training program, you also get some other benefits, such as you can get the course e-certificate after submitting all of assignment. You can get all of materials, mainly slide, PDF. You can get all of practice code, as well as you also get the recorded class. If you miss any live training program, then you can easily cover using the recorded class. Another is the lifetime testing support. Basically, as a beginners, when you want to learn the Google Earth Engine platform, you face a lot of problems. So that's why we are also providing the lifetime testing support regarding this online training program. Okay, so that's why you can easily learn. Okay, don't worry about that, you can easily learn. And if you have no knowledge about the coding, or if you have no knowledge about the Google Earth Engine or remote sensing, don't worry about that. In this online training program you will learn everything from beginners to advanced level, and after completing this online training program you can do any types of remote sensing analysis very quickly and efficiently using the Google Earth Engine. So don't waste your time. If you want to join our upcoming batch on 15 November, as soon as possible just contact in this WhatsApp number, also contact with this email. I already give all of information in the video description. Just check it and then contact. Thank you for watching that. Stay safe, stay safe.